Ohm's law describes the way current flows through a material when different levels of voltage are applied. Some materials, like the electrical wires that present a little resistance to the current flow in this type of material, is called a conductor. This conductor is placed directly across a battery. For example, a current would flow. George Simon Ohm, a German physicist, was the first to verify the Ohm's law experimentally. Ohm's law is vitally important to describing electrical circuits. It relates to the voltage the current flow with the resistance value, moderating the relationship between the two. Ohm's law can be used to control the amount of current in a circuit, adding resistors to reduce the current flow and taking them away to increase the amount of the current.
At this juncture, I will present and tackle to you the objectives, material, and the diagram of this experiment. The objectives of this laboratory experiment is to verify the Ohm's law principle. The specific material or the apparatus that was utilized is the PHET simulator, the circular construction PC, or the direct current. The following slides that will be represented are the diagrams from trial 1 to trial 5. Each diagram includes one resistor, a battery, and some wires in order to determine the current and the voltage. Additionally, the ammeter and the voltmeter are also included, which are also the essential parts of the simulator circuit.
For the procedures, we, the students, access the PHET simulator, circuit construction kit DC. Then, in there, we identify the important parts of the circuit and analyze how to utilize the respective apparatus. The PHET simulator includes the wire, battery, light bulb, switch, voltmeter, and ammeters. Basically, these were used to construct our circuit. To construct the circuit, first drag the voltmeter and ammeter, followed by the wires, battery, and fixed resistor. Secondly, we drag the switch. These materials that were dragged in the medium of the screen of the PHET simulator were respectively placed in according to the student's choice of layout. Third, connect the ammeter, switch, battery, and resistors using the wires. The value of the resistance can be changed conferring of the student's choice. Next, connect the probes of the voltmeter to the opposite sides of the resistor and eventually measure its voltage. In order to close the circuit, simply click the bottom part of the switch. When the values are already shown or revealed, take note of it right away. Encode the following shown from trial 1 to trial 5 in the table given in the laboratory experiment number 4 worksheet. Take note that the value of the voltage is held constant. After encoding the data of each trial, understand and analyze the diagrams truly. Lastly, proceed to the next parts of the experiment by answering the computation, discussion, observation, analysis, and conclusion.
At this moment of time, let me discuss the computation in the table of this laboratory experiment. From the trial 1 to trial 5, the experimental voltage V must be held constant to the value of 20 volts. As shown in the table, the value of the resistance R is correspondingly increasing, specifically from the value of 5 ohms, 10 ohms, 15 ohms, 20 ohms, and lastly 25 ohms. Then, the value of the experimental current and the theoretical current are correspondingly decreasing from the value of 4 ampere 2 ampere followed by 1.33 ampere to 1 ampere and lastly 0.80 ampere. Also, the value of the theoretical voltage from trial 1 to trial 5 is held constant with a value of 20 volts. In finding the conforming values of the theoretical voltage and the theoretical current, we use the following formulas. The current I is multiplied with the resistance R in order to determine the theoretical voltage. While to determine the value of the theoretical current, we must divide the value of the voltage by the resistance R. The following images are the table and the computation of this laboratory experiment in order for you to understand and verify the Ohm's principle.
Our discussion states that Ohm's law was applied in this laboratory experiment. This law describes the way current flows through a material when different levels of voltage are applied. There is a relationship between electric current and potential difference. The current that flows through most conductors is directly proportional to the voltage applied to it. Mathematically, this current-voltage relationship can be written as V equals to IR. Ohm's law can be used to control the amount of current in a circuit, adding resistors to reduce the current flow and taking them away to increase the amount of current. Currently, for the observation in all of the trials, it must be observed that the theoretical voltage from the battery is constant at 20 volts. In the first trial, with a resistance of 5 ohms, the measured current is 4 amperes with a measured voltage at 20 volts. This matches up with the theoretical values of current and voltage at 4 amperes and 20 volts respectively. In the second trial, with a resistance at 10 ohms, the measured current is 2 amperes with a measured voltage at 20 volts. This matches up with the theoretical values of current and voltage at 2 amperes and 20 volts respectively. In the third trial, with a resistance at 15 ohms, the measured current is 1.33 amperes with a measured voltage at 20 volts. This matches up with the theoretical values of current and voltage at 1.33 amperes and 20 volts respectively.
At this point, let's discuss for the continuation of observations. In the fourth trial with the resistance of 20 ohms, the measured current is 1 ampere with the measured voltage at 20 volts. This matches up with the theoretical value of current and voltage at 1 ampere and 20 volts respectively. Lastly, in the fifth trial with the resistance of 25 ohms, the measured current is 0.80 ampere with the measured voltage at 20 volts. This matches up with the theoretical value of current and voltage at 0.80 ampere and 20 volts respectively. Analysis. Based on our calculation, the experimental current and theoretical current are exactly same in all of the same 5 trials. The resistance in the first trial is 5 ohms and the experimental voltage is 20 volts. The second trial adds 5 ohms for a total of 10 ohms. And the experimental voltage is the same as the first trial, which is 20 volts. It is then multiplied by 5 ohms for the third, fourth, and fifth trials. Each trial is used the same experimental voltage of 20 volts. Throughout the 5 experiments, the theoretical voltage is similar to the experimental voltage, which is 20 volts.
On this stage, I will tackle the conclusion. Therefore, based on the results shown in the table, as learners, we concluded that as the resistance increases, the current of both experimental and theoretical are decreasing. Thus, it indicates that the two variables, electric potential and resistance, affects the amount of current in a circuit. Furthermore, we conclude the current in a circuit is directly proportional to the electrical potential difference expressed across its ends, and inversely proportional to the total resistance offered by the external circuit. We determined that our theoretical values for current and voltage match with the experimental values for current and voltage. We were able to successfully use the Ohm's law equation to find the correct values of current and voltage.
I hope that you learned something from us. Just remember always, the important thing is not to stop questioning. Quote that the curiosity has its own reason for existence.